Hello everyone, this is Mathematics and we are here with the second section of chapter Quadratics, which is completing the square. So guys, I just want to tell you that in this whole section, our objective is to write the quadratic that we are given in the form a times x plus b squared plus c. This is our whole objective in this section. And you may think that, okay, you told me about other ways of solving a quadratic. You told me about factorization. You told me about the formula. And what's the use of doing completing the square? So like if I have factorization, I can solve the quadratic by doing the factorization. If I cannot use the factorization, formula is the answer anyways. So what's the use of completing the square? Guys, the main use of completing the square is not here for solving the quadratics. The main use of completing the square is in the next sections of the same chapter, and we're just gonna get into it. For now, we're just learning how to solve these. And by solving these, I mean how to complete the squares. How to complete the square of any quadratic that we are given. So before that, the textbook has introduced you two formula for in order for you to use for completing the square, and these are the formula. I'm not going to use this formula, but I'm going to mention them for you to choose if you want to go by my method or just to use the formula that the book has given you. So if you have your quadratic in the form x squared plus bx, after completing the square, it will become x plus b over 2 squared minus b over 2 squared. Well, this is the first one. And as for the second one, if you have ax squared plus bx plus c, then your quadratic will become a times x plus b over 2a squared plus squared plus c minus b squared over 4a, and this is it. What is this minus saying? So ax squared plus bx plus c by the formula becomes a times x plus b over 2a squared plus c minus b squared over 4a. So I'm just gonna write examples and we're gonna do it together so we can see how the process goes. As for your example, you are given the equation, or rather say the expression, plus 6x minus 11, and they want you to complete the square of this one. So the thing is, guys, for completing the square, you always refer to the first two terms of the quadratic. So you just refer to this section, right? So you just refer to this section. And all I have to do is with this section, x squared plus 6x. So guys, I know that what was my formula? If I had a plus b squared, it would have become a squared plus 2ab plus b squared, right? So this one here was the product of a and b multiplied by 2, right? This is our 6. The 6 is just this, right? So I'm just going to delete this one. So x squared plus 6x, we're just representing x plus 3 squared. But wait, x plus 3 squared, if I expand it, it will become x squared plus 6x plus 9. But I don't have a plus 9 here. No worries, you can give the expression the plus 9 that it needs. Plus 9, but doesn't it change the value? It does, but no, as long as you put another minus 9 here. So let me just remove all of these. So you will have x squared plus 6x plus 9 minus 9 minus 11. This is 0. So it doesn't affect the total thing that we are dealing with. So I can complete the square of these first three terms. And it will become x plus 3 squared minus 9 minus 11. Or by simplifying, it will become x plus 3 squared minus 20. And this is your answer. This is your answer. So, another example. So, as for your next example, you're given 2x squared plus 8x plus 5. And you're wanted to write this one as in the completing the square form. So, you can use the formula, guys. You can use this formula again. You can use this formula. But I'm going to just go with another way and you'll see that. So, guys, I told you, whenever in completing the square, when you are given a quadratic, you are just dealing with these first two terms. So, let me see what's happening there. Guys, 2x squared plus 8x. Well, something interesting is happening. What is the interesting thing? I can factorize a 2 from this one. Not x, not 2x. A 2 from this one. So, I will write the expression as 2 times x squared plus 4x in brackets plus 5. Hey, right. So, plus 5. And so, you see that x squared plus 4x is just, right. Right, it is in the expansion of x plus 2 squared, which will be x squared plus 4x plus 4. Oh, no, wait, I don't have this plus 4 here. So, what should I do? Guys, I told you, you're just gonna put another minus 4 here, so nothing will change. Let me just erase the whole thing. And so you can write it as 2 times x squared plus 4x plus 4 minus 4. And this is 0. So it affects nothing. Plus 5. So you can complete the square of this one. See, you can complete the square of this one. So I'm just going to write it down. 2 times x plus 2 squared minus 4 plus 5. And you're just going to expand these brackets. Okay? You're just going to expand these brackets. So it will just become 2 times x plus 2 squared minus 8. Don't forget to multiply the 2 by minus 4 as well. Plus 5. And by simplifying, I will get to 2 times x plus 2 squared minus 3. And this is my answer. So, okay, with just ensuring, just to tell you that even the formula works, I'm gonna do it with formula as well. So let's just use another color. Let's use green. Okay, so 2x squared plus 8x plus 5. 2x squared plus 8x plus 5. And if I had ax squared, okay, ax squared plus bx plus c, it would have become a times x plus b over 2a in brackets squared plus c minus b squared over 4a in brackets again. So, what is my a? A is equal to 2. What is my b? B is equal to 8. What is my c? C is equal to 5. So I'm just going to write it as 2 times x plus 8 over 4. 2 times 2 is 4, guys. Squared plus, what is c? 5 minus b squared 64 over 4a, 4 times 2, 8, which will be 2 times x plus 2 squared plus 5 minus 8, which is 2x plus 2 squared minus 3. And this is the same answer as this one, guys. So you see, you can use either formula or my method, doesn't matter. And they are both correct. And thanks for watching this video. Do not forget to like the video and subscribe our channel. So till the next session, I will see you guys.